All right, so this is a little practice here, just kind of an example of how to do a pedigree when you're reading a family story. And hopefully you can use this to do your genetic counselor project, and it should help you along. So the story that I'm talking about is here on Google Classroom. It's in Unit 5. It's called Practice Family Story. So you can go there. You can open this up. I'll refer to this a couple times as we go, as we are reading. So you can freely get to here and read through as we are talking, okay? All right, so let's go ahead and get started. I'm going to bring up my whiteboard. All right, so let's go ahead and get started. So here's our whiteboard, which we're going to draw a pedigree, and here's the story that we've been working in. So, okay, let's go ahead and just start reading it. So it says, John and Julie Johnson are going to have a new baby son, not soon. They are of African-American descent and are worried about their baby having sickle cell anemia. So they are looking for some advice from a genetic counselor. You are their counselor. So read the family history below to construct a pedigree for sickle cell anemia in their family. Okay. And so it says we're going to have John, age 32. And since it just starts out with John, I'm going to go ahead and do his family first. Okay. So when you're doing these, a good thing is to split them up into as many pedigrees as you can, and then go ahead and bring them together. So we're going to do John here. We're going to do him at the top. So it says John, and he's 32, okay, and has 2 parents and 3 siblings. So I'm going to go ahead and give John, that's going to be above him. He's going to have 2 parents, okay, and it says he's going to have 3 siblings. And it says, and I'm not going to add those quite yet. I'm going to keep reading. So John's parents are healthy and show no signs of sickle cell anemia. So that's when, okay, so we have no signs of sickle cell anemia. So we're going to leave them not colored in. And then it says all of John's siblings are younger than he is and are married. So that tells me right there that he's going to have room because all of his siblings are married. So it's John and his 3 siblings, so there's 4 of them. So I'm going to go ahead, I'm going to actually use probably my entire board here, and I'm going to zoom out so that you guys can see it all. But I'm going to go ahead and add in John's siblings. Now notice, I made enough room so that I can add their family, John's siblings' families as well. That's very important. Okay. And then it says John's sister is 30 and is married. Now, did tell us that John was the oldest because everybody else was younger. So there's John. And then it says he's going to have a sister who's 30, okay, is 30 and is married. So she's married. So we're going to give her a husband, okay, with 1 healthy daughter and 1 son with sickle cell anemia. So then they had children. And it didn't give you the ages, so that's when you can put them in whatever order, just the order you read in. So 1 daughter and 1 son, and it says the son does have sickle cell anemia, so we're going to go ahead and fill him in. It says John also has 2 twin brothers aged 28 who are both married. So he has 2 brothers, and it says they're the same age, so you can put them in any order you'd like, okay? And they are both married, okay? So married, so we'll get them married here, okay? Move my board over a little bit for you. And then it says, one of John's brothers has a daughter with sickle cell anemia and the other brother has no children. So I will go ahead, I'll just give this brother, it didn't define, a daughter with sickle cell anemia, and this one does not have any children. So that is John's family. So then we're going to go ahead and we're going to stop. And then we're going to look at Julie's family, okay? So we can make another pedigree, okay, for Julie. And it says Julie does not know much about her family as she is adopted. So really all we have is Julie. So we're going to go ahead and just add her in because we don't have to add anything. We could add if she had parents. So at first, we're just going to add Julie here. If we could have added her here and then added her parents above them if she had any, but we don't know any information. So Julie is just on her own. So that's how we've made her pedigree and then we've added it to the top. And you can do that, make 2 different pedigrees and add them as well. Okay, but then it says John and Julie currently have one daughter, age 3, who does have sickle cell anemia, and they are pregnant with their second one, as it said on the top. So we're going to give them one daughter, and she has sickle cell. Okay. Now, when we're dealing with this, and we're going to use the letter, let's say, we're going to use the letter F. So we're going to have always 3 genotypes, right? We're going to have the homozygous dominant, we're going to have the heterozygous dominant, and the homozygous recessive. Okay? Those are our 3 genotypes to choose from. So then we can start filling in our genotypes. And remember, anything that is filled in will be that recessive. And we figured that out in class because there weren't many of them that had it. So that means it has to be recessive. Notice it's only showing up in one generation. So once we figure out that this child here is homozygous recessive, then we know the parents already are heterozygous because they both have to have a little f to give. Same here. Now this daughter doesn't have any, so we can't know her genotype. So we're going to give her a question mark. These brother and sister-in-law, we don't know because they don't have any children. But here, where we have John and Julie, who are our important ones, we know that they have to be heterozygous because they have an affected daughter. And the same here for the parents. We're not really sure what they might have. We know one of them probably has a little F because all of their children do. Not sure about this son here, but most of them do. Okay, so that is actually how you would construct the pedigree, and that's how this one should look. So you have to maybe separate them out, then bring them together the best you can. Okay, and the second part we're going to do is a genetic counselor not only makes this and figures this out to figure out the genotypes, but then does a Punnett square. Remember, the Punnett square will tell us what that baby, if that baby will have sickle cell anemia. So we're going to do a Punnett square to give them an advice if we should do more genetic testing. So both John and Julie are heterozygote, if you remember. And so if they're heterozygote, this is what our pedigree or our Punnett square should look like. Okay? They're both heterozygote, so it's big F, little f. And so John, I'm going to just put on top, and it doesn't matter which order they go in, and then Julie on the bottom. And remember, you can only have one allele per box here because they are the law of segregation. Okay? And so then when you cross them, you'll have big F here, big F, little f here, big F, little f here, and little f, little f. And each box is worth 25%. So if I start listing it out, big F, I see once, so I got 25% chance of it the baby being that genotype. Heterozygous, big F, 50% since I have 2 boxes with those. And then little f, homozygous recessive, I have a 25% chance. So really, I have a 25% chance of the baby having sickle cell anemia. And then if I looked at my phenotypes, remember that's what they look like. And this genotype would be normal, as with the heterozygous would be normal, and the recessive would be sickle cell. And so if we were going to say of the phenotypes, what percentage would be normal? It'd be 25 plus 50, give me 75% chance of being normal and 25% chance of having sickle cell. You're going to do the same kind of idea on your genetic counselor project. If you guys have any questions, please feel free to ask.